Welcome, this is another Khan Academy support video. Congratulations on making it to the last Khan Academy required assignment for the week, the one that's called Slope Intercept from 2 points. This is a lot like the one called Slope Intercept equation from a graph, where you need to come up with your own linear equation in slope intercept form. But the challenge is now, instead of giving you a graph, they only provide you with 2 points that the line would pass through on a graph. In this case, they tell us our line passes through 3 and -1, and also through the point 4 and 7. And I'm going to mark a little x, y up here because these are ordered pairs listing the x value first and then the y. Rather than make a whole graph and try to measure the y-intercept and then measure the slope on that graph, I want to find a more efficient way to come up with an equation here. I need to know 2 things to write any linear equation. I need to know the y-intercept and I need to know the slope. Recall that a y-intercept represents the value for y when x is 0. And here, neither one of these points is the y-intercept, so I just don't know the y-intercept yet. I also know that slope represents my rate of change, how much the y changes divided by how much the x changes by between 2 points. And on a graph, we were using rise over run to measure that slope number. If I'm just given 2 data points and I can't visually draw it out on a graph, I need to measure the y change and the x change by looking at the values of the numbers. Here, and focus on the whiteboard, I see the y value starts at -1 and it transitions or grows to +7. So there, our y change, our y grew, and I'm going to put a +8 here because the y value just gained 8 units to go from -1 to +7. And during that time, the x value went from +3 to +4. The x value gained as well, but it only gained 1 unit. So this tells me here that my m, or my slope for this equation, for this linear relationship, is going to be +8 over 1. So my first job, if I'm given 2 points and they ask me to write an equation, is to use those points to measure slope, kind of like you did a few assignments earlier. Here our slope is 8 over 1. Once I know that the slope is 8 over 1, I can go to my y equals mx plus b equation, and I can replace the m and the mx plus b with the slope of 8. And my job now at this point, I need to find what the y-intercept is to finish this equation. I know I've got y equals 8x because that's the slope, but I don't know what the b is yet. That's really the thing I don't know yet that I'm trying to figure out. So to find the b, to find the value of that y-intercept, I'm going to go ahead and take either one of these data points. I'm going to pick the second one because it has positive numbers and I like positive numbers. But you can pick either data point and plug it into the equation because this equation needs to work for these points. So I'm going to replace the y with 7 from this second data point. And this point tells me if y is 7, x needs to be 4. So here, again, I plugged the m in with the 8 because I know our slope is 8. And then I took one of the data points I know the line passes through and I plugged that, the 4 for x and the 7 for y, into the equation. Now the only thing left is the y-intercept, the b, and I'm going to solve for that. 8 times 4 gives us 32, so the equation becomes 7 needs to be equal to 32 plus whatever the y-intercept is. I'm going to subtract 32 from both sides of this equation because that's how I'm going to get the y-intercept all alone, or solve for that b, by canceling out the 32 with a -32. 7 minus 32 gives me -25. And so this is how I found the y-intercept of -25. Instead of writing plus, I'm going to simplify it. Adding a -25 is the same thing as subtracting 25. I'm going to show a couple more examples because this is definitely a bit more challenging, but the key concepts remain the same. If I want to write a linear equation in slope-intercept form, I need to know the slope and the y-intercept. It just becomes a little more challenging to find that slope and y-intercept if all they do is give me 2 points. For the second example, the next problem, -9 and 7 is the first data point they give us. And then the line also passes through -6 and -3. So if my line passes through these 2 things, these 2 points, I'm going to measure the slope between those 2 points, the rate of change. The y value goes from +7 to to negative 3. It's losing value to go from positive 7 all the way down to negative 3. I jump down by 7 to get to 0. I jump down by 3 more to get to negative 3. That's a total of losing 10 units. If I go down by 10 units, that takes me from 7 to negative 3. So the y lost 10 units, and during that time the x value went from negative 9 to negative 6. That's gaining value. If I go from negative 9 to negative 6, I'm getting closer to 0. I'm actually gaining value, and specifically we're gaining 3 units of value. So that tells me if our equation is built off y equals mx plus b, at this point I now know the m for the line that passes through these 2 points. The m, the slope, is negative 10 over 3. The y is losing 10 as the x gains 3. So I'm going to plug that into my equation. My equation becomes y equals negative 10 over 3 times x plus b. All I did was replace the m, the slope, with negative 10 over 3. Now I'm going to go ahead and take these data points. I'm going to take the second one, plug this into the equation. I'm going to replace the y with negative 3. And I'm going to replace the x with negative 6. Negative 10 times negative 6 is positive 60. And 60 divided by 3 is 20. So recapping what happened there, I had negative 10 over 3 need to multiply with negative 6. And a negative times a negative makes a positive. 6 times 10 is 60. And 60 divided by 3 is how I got to that 20. So I have negative 3 equals 20 plus b. I need to get the b all by itself on the right side of that equation, so I'm going to subtract 20 from both sides. b is equal, negative 3 minus 20 gives you negative 23. So this is a tough equation. Khan Academy doesn't mess around. You have negative 10 over 3 multiplied with x. Remember, don't put that x in the bottom of the fraction. Make sure it's its own number, and negative 10 over 3 is just a coefficient. And then the y-intercept here is negative 23. Certainly, as you see, a bit of a challenge, but work through, find the slope, find the y-intercept. We're going to give you one more example here. Same process, they're going to give me 2 data points that our line passes through, so I need to use those 2 data points to first measure my slope, and then we can use the slope to work out what the y-intercept would have been. Here it passes through the point 2, 1, and it also passes through the point 5 and negative 8. So that's on my whiteboard here. I look at the y change first. That's the numerator for slope, how much the y changed by. And it went from positive 1 to negative 8. That's losing value. It lost a total of 9 units. And during that time that y lost 9 units, x went from positive 2 to positive 5. The x value was gaining during that time. It went up by 3 units. So that gives me a y change of negative 9 for my slope, an x change of positive 3, and if the slope is negative 9 over 3, that simplifies to a slope of negative 3. So that's how I know my slope is negative 3, or it's going to be y equals negative 3x plus whatever the y-intercept is. So now I'm going to take that negative 3, my slope, and I'm going to plug it into my equation. Y equals negative 3x plus whatever that y-intercept is. This helped me find my slope, and I'm also going to go back and use this first data point with 2 simple positive numbers, and I'm going to replace the y with 1, and I'm going to replace the x with 2 because this equation needs to work through the point 2 for x and 1 for y. So now my equation says 1 is equal to negative 3 times 2 plus b, or 1 is equal to negative 6 plus b after I do that multiplication. I want to isolate the b as always. I want to get that b all by itself so I know what value it has. That means I need to cancel out the negative 6, and I'll use a positive 6, or that inverse operation of adding to cancel out a negative. That tells me that b, or the y-intercept here, needs to be equal to positive 7. And that's how we arrived at that equation. This is certainly a bit of a challenge on the sixth one. If you've got questions, I'm happy to work through with this one-on-one. Feel free to send me an email, and I'm happy to jump on Zoom and help you work through it. Really great work this week if you've managed to get this far and this stuff makes sense. There will be a few challenge assignments that I'll post probably by Wednesday to keep you moving on Khan Academy. For now, you can definitely head over to IXL if you're looking for more of a challenge. Keep up the great work.